We discussed about bind mounts and we discussed about Docker persistent values. Again, using persistent values, we created a local values. We created value using local driver. So where do these values will live? Basically in the var lib Docker, under that values, under that your value name, this is the mount point which is created under the host machine. Now, as we discussed yesterday, we can create external storages, external values also. We can mount with external values. So this is your server, your host machine. You have a Docker. When we create containers, if you use values, you can mount with local values or you can mount with external values, external storages like NFS. If you are using AWS, right, you can mount with EBS. You can mount with S3 also. Basically, you can attach. Basically, you can upload data to S3 also or EFS. If you are using Azure Cloud, if you are using Azure Cloud, there is a storage called Azure File, Azure Disk. Based on your infrastructure, you can upload. You can use external storages. Yesterday, we created a local value. Yesterday, we created a local value using local driver. So container data, your container data is mounted with, container directory is mounted with the local directory, basically in this server. This is local value. If required, we can mount with external storages. So there are different Docker volume drivers. Okay. You need a driver. You need a volume driver so that you can mount with the respective storages. If you see Docker volume plugins, if you see the official documentation itself, right, there are some drivers. So these are the value plugins, right? If you want to, if you are using Azure, you can use this driver. First, you need to have this driver set up in your Docker server. For AWS also, there are some drivers. If you see, these are the value plugins. Network, storage plugins. If you see, there is a plugin called this Rexray/plugin. If I use this one, I can mount with AWS related storages. I can use to create and attach EBS volumes to the containers. It supports EC2. Inside that there is again some plugins, EC2 plugin, S3 plugin. If you see, I open the official the GitHub of the Trexray driver. If you see, we can use EBS plugin or EFS plugin or S3 plugin so that we can mount with these storages. If you see, if I want to install, right, I can follow these instructions, right? If I want to use EBS volumes for my containers, I can install this volume driver by executing this command so that I can create a EBS volumes and I can use those EBS volumes. I can use those EBS volumes for my containers. So what is the use of this driver, right? Volume plugin or volume driver plugin. If I install this plugin, if I create a volume something like this, if I create a volume, who will create EBS? Do we need to manually create EBS value in the AWS, or the driver will create and driver will try to attach when we are using? So this is one software. This is one basically one program, right? This driver is nothing but one software, one program. It is taking the, it is doing the abstraction basically. Instead of you are creating a volume, EBS volume, and you are attaching to that server and you are mounting to that, right? This driver will take care. So I need to install the driver. Then I can create a value. That value I can attach with the container, the EBS value. If you want to use EFS, right, you can use EFS. You can, attach EFS also for a containers. You can mount. So now let me show this EBS. Let me connect to my server first. Yesterday we created a container. This, the front end container is stopped. Let me start. I think it got deleted. Okay, fine. Let me, I think I deleted the front end application. Let me create. The front end, basically the Java application container. So we have the application container and also the database container. Now what type of volume we used with this database container yesterday? If you inspect also, you will come to know. Docker inspect container. If you see the volumes, right? Here, what type of value we used yesterday? This is the value, type is value, name is this. This is the container folder, this is the mount point. And what driver we used? So here, what driver we used? This one, local. First we use bind mount, later we use Docker persistent value. So now this is using Docker persistent value with local driver. With local driver. Now I want to use like external storages. Instead of local file system, I want to mount with external file systems, external storages. So I need a driver. By default, we have only local driver. Now I can install this EBS driver. So I can install this EBS driver. This is the command. So that I can use EBS values. So what I need to provide, guys, what they are expecting here while installing the driver. What is this? What I need to replace here? The AWS. So this driver requires permissions, right? This driver requires permissions to create AWS resources. This driver basically requires permissions to create a EBS values. We are not manually creating. This driver will create. So what we need to give here, what they're expecting here, what is this EBS access key and EBS secret key? Is nothing but your AWS access key and secret key. You can provide your, as you already, we already discussed in AWS, you can create IAM user and you can provide that IAM user access key or secret key, or you can provide a root user access key or secret key. Now where can I found if I want to use root user access key and secret key? This is my AWS account, right? What you can do, as we already discussed, you can create one IAM role with easy to full access. You can create one IAM role and IAM user, and you can use that user access key or secret key. For now, like I'm taking root user access key and secret key. Where can I find root user access key and secret key? If you log in as a root user to your account, here on top of your username, you can see my security credentials. Here you can use this user access key and secret key. If you don't have already handy, maybe you can create a one. This is my access key. This is my secret key. So first I'll install the plugin where I want to use EBS storages as a volumes for my containers. So it is asking some permissions. Yes, I want to give. Yes. So we install the plugin. So Do I need to install this plugin each time whenever I want to create a EBS values, or it's just a one-time activity? It's just one-time activity. So I have a driver. I have a driver volume plugin. So now I want to use EBS values for my containers. I want to use EBS values for my containers. I no need to manually create. I can execute something like this. Docker volume create -d. What is the driver name? This is the driver name, rexray/EBS. MongoDB EBS. So now what this driver will do? This driver will create one EBS for you. If you see, we already discussed what is EBS. If you see, as of now, I have only two root volumes because I have two servers. For this server, this is the root EBS. For this server, this is the root EBS. Now in this server, I installed that driver. Now I am trying to create a value using the driver, docker value create -d rexray/EBS MongoDB rs. So it will create a value for us. Now if I see docker volume ls, now this one, using which driver we got created this value. Now if you see this value, using which driver? Using this rexray/EBS. So it's not a local value. If I inspect this value, what type of driver we used? EBS driver. So where it is created? In AWS. In AWS it has created. Now if I refresh here, who created this EBS value? As of now it's available. We have not yet used with our container. If you see, since I have not mentioned the size, default it has took 16 GB of size. It has created one EBS value. It's available. Did we created manually this one? This one? The driver has created. Now I can use this value with my container. As of now, this is using local value. So let me delete this. Guys, again, we cannot do the value, use value mounting while the container is in use or running. So I'm deleting it. Now I will use that value instead of local value. Instead of this value, I can use this one. So now here I can mention Mongo DB EBS, this value name. Now the driver we used Rexray driver. So Docker is trying to mount this value. Now this EBS is attached with this container directory. So where do our container data live now? Is it part of your server file system or it's part of this EBS value now? So if I execute Docker PS, we are using this container. If I inspect this container, so what type of driver we are using? This one. Basically, we are using EBS. Now, if I go and see here, this one, it is attached to that server, our deployment server where container is running, and it is mounted with which directory? If you see, this is attached to that server where we have created a container, and it is mounted with which directory? That container directory /data/db. Now, whatever data is getting generated under that container, where exactly it will live? Let me get the public IP of this server. So where exactly now the container is maintaining the data? Is it part of the server root or it's part of additional EBS now? Whatever data that container is attached with EBS value. This container is attached with EBS value. Now, if your root, this server is crashed, your root file system is crashed, you are not able to recover this root file system. Now, do you need to worry about container data? Where exactly they live? In the additional value. And periodically you can take a AWS concepts, right? Periodically you can take a backup of this value. So what data is there inside this? Periodically you can take a backup of this volume also. What data is there inside this? Is it having your complete Docker related information or only the database container data? Only the container data. The data/db, your Mongo database container data. So even though this server is gone, still you have a EBS value. You can create another Docker server. Suppose for some reason this server is gone. That will not happen. There are a lot of ways to recover. But if this server is gone, still you have a data in this additional value. You can create another Docker server. You can create another Docker server. You install this driver. You install this driver, it will reflect there, that value, so that you can use that value. So we can use with external storages like this. But what do you need? You need a driver. Based on your requirement, what type of storage you need, based on that you need to install the driver and use it. Volumes are very important. So volumes are very important, and don't execute this command docker volume rm or docker volume prune, unless until you have a very clear instruction, unless until you have very clear instructions to delete your values. If you delete your values, will you be able to recover your data? If you delete your container, if you have a value, you can recover your data by using that value, right? Don't delete the values unless until you have a clear instructions. So this is about volumes. Volume is nothing but some storage. That storage is getting mounted to the your container file system, so that the container data will exist irrespective of your container life cycle. So now networks is for what, guys? Networks is for what? We have a Docker networks. This is for what? Networks is for communication. Networks is for communication. Volumes are nothing but storage. Storage for data. Image is basically what for your in Docker? Image is what basically? A package which contains everything to run a piece of software as a container. What is container? It's a running process. Running instance of an image in which application process is running. So this is basically a package which contains everything to run a piece of software. This container is basically running instance of image where our application is running. If required, container will be used, container will be attached with value, and containers will be running in some networks. If one container has to communicate with other container, both the containers should be there in a same network. Guys, understand the concept. Don't by heart commands, or don't like do like step 1 execute this, step 2 execute this, right? Try to understand the concept and how to apply these concepts, so that you can learn the subject easily. Don't by heart execute docker run, execute docker value first, docker network, like step 1 do this, step 2 do this. So don't follow that approach. Try to understand the concept. Why docker first? Why we are going for a docker? Okay, if I have to use docker, then what needs to be done if I want to deploy my application as a container? Okay, you need an image. So if you need an image, you need to write a docker file. So what is docker file? What are the instructions? You have an image. Once you have an image, how can I maintain that image, or how can I share that image? Then you will understand repository, docker repository or registry, public repository, private repository. Then container. While creating a container, you are using, or you are applying network concept, you are applying volumes concept, so that if I use volumes, if it is a stateful application, I can retain the state of the container. If it is a stateless application, do I need to create a volume? Do I need to use volume? Not required. But even though if it is a stateless application, if that application has to communicate with some stateful application, both are running as a containers. So the container should be there in same network. So try to understand the concept. We have to apply these concepts. Right? That is what we are doing now. Now, so far we know how to create an image, how to deploy an image, and how to use networks, and how to use volumes for container. Now, this is also persistent volume. Whatever I created, this external storage, also persistent volume. What is the meaning of persistent volume, right? It will maintain the volume information, what type of volume you are using, right? What type of volume you are using, and where exactly, like what driver you are using, right? You can use n number of volumes. You can use n number of volumes, like -v you can apply with n number of directories, but we don't, you know, mount same directory with the two different volumes. That is not required, right? This is also highly available EBS, right? You can use AWS concept. This EBS is highly available data storage, right? And periodically you can have a backup of your EBS. You no need to mount with the two different volumes for the same container directory. If required, you can do that. So this is about volumes and networks. Then we have a one concept called Docker Compose. What is Docker Compose? Why do you need Docker Compose? What is Docker Compose? And why do we need Docker Compose? So suppose I have to deploy some application. If that application consists of multiple services, basically multiple images. Suppose I have some application. That application consists of multiple services, multiple microservices, right? And I want to deploy all those containers. So far, how we are deploying the containers? How we are, what we are doing? We are executing Docker run instructions. So you may have a require, like, in real time you have like multiple microservices. Your application will have a multiple microservices. Each microservice is one image. Each microservice is one image, right? So if you want to deploy, if you want to deploy, you may need to execute lot of Docker commands. You may need to execute lot of Docker run commands. Let me take this scenario itself, this application. And it is using database. So how many commands we executed, guys, to deploy this? Build, I am not talking. Build is separate, right? Deployment. How many commands we executed? What are those? What are those we executed? Docker run for Spring application, the front end application. Docker run for which one? Mongo database. And also, did we created a value? This guy requires a value, right? So what we have done? We have executed Docker volume create, and also we created a network. We created a network, we created a volume, then we created containers. So to deploy this application which has only 2 images, how many commands we executed? Which has only 2 images, I have to execute 4 commands. Suppose you have one application, that application have 10 microservices. That application has 10 microservices. Suppose you are trying to deploy into production. If I follow the commands, if I use commands for deploying, I may need to execute lot of complex, long Docker commands. The complexity is proportional to the number of containers involved. So is there a better way I can manage the container deployments instead of executing these many commands, right? That is where Docker comes, Compose comes into picture. So Docker Compose is a tool. Docker Compose is a tool using which we can define and run multi-container applications. What is multi-container applications? Your application has a multiple containers, multiple services. Docker Compose is a tool using which we can define and run multi-container applications. Multi-container applications. So instead of executing lot of commands, we can use Docker Compose, in which we can define your containers information, and you can use that file to deploy that application. So as I told, in real time, one application consists of multiple containers, basically multiple services. And one container is dependent on another container. Some scenarios you may have a requirement like, first you have to create this container. Some scenarios you may have, first you have to create this container, then only you can create this container. In that case, you need to maintain the order also. You have to maintain the order also. First create this container, then only create this container. You may have a requirement, the dependency or startup order for your containers. So if I want to deploy, I have to execute lot of Docker run commands. And complexity is proportional to the number of containers involved. So how to solve this problem? I don't want to execute lot of Docker run commands if I want to deploy. So that is where the Docker Compose comes into picture. Docker Compose is a tool for defining and running multi-container Docker applications. You can define all your containers information in a compose file. Using that compose file, you can deploy the containers. and it's a YML file. So we can use Docker Compose to define and run multi-container applications. So let me take this example only. To deploy this application, right, we have executed lot of commands. So what we have done, right? We created a network. Without Docker Compose, what we have done? We created a network. If I take this example itself, without Docker Compose, we have executed these commands. If network was not there, we created a network. We created a network. We created a network. And we created a volume also. Whether you are using local volume or network volume, you created a volume. And we created a container. Something like this. To deploy this application without Docker Compose, like these many commands we executed. These many commands we executed. We created a network, we created a volume, and we created a containers. Suppose my application has 10 images. I may need to execute lot of Docker run commands. So instead of doing this way, I can use Docker Compose. Docker Compose is a tool using which we can define and run multi-container applications. It's a YML file. So Docker Compose contains information about our containers. Docker Compose contains information about our containers, using which I can deploy containers. We can integrate, we can use Docker Compose in a Docker Swarm also. We can use Docker Compose in a Docker Swarm also to deploy the application in a Docker Swarm. It is competing with Kubernetes. So it's a YML file. It is YML file. We have to define this information in a YML format. Again, YML is one file format, guys. The way you have a XML, the way you have a TXT file, the way you have a HTML file, that is one file type, using which we can define some information. So now YML is everywhere. YML file formats you can see everywhere. If you are using Docker, you can see compose files. If you are using Kubernetes also, you can see Kubernetes manifest files as a YML files. If you are using Ansible, Ansible also kind of a YML file. In the Ansible also you'll use YML files. It's one file format. YML is one file format. We are going to define our volumes information, containers information, networks information in a compose file in the form of YML. Okay, so far you know XML, right? If you see, XML will have a well-defined tags. If you take any XML like palm.xml, right? It will have a well-defined tags. So if you see, this is the starting tag. There will be a ending tag. If you see, this is one starting tag, there will be a ending tag. And within this tag, these are the child attributes. The build has this information. Plugins. And again, there is a starting tag, plugin. So XML is a well-defined document. So there will be a starting tag, there will be a ending tag. If you see project is a parent. This is one child. This is another child attributes. If you see dependencies, starting and there will be a ending. Dependencies. Inside that dependency. So XML is a well-defined document. It will have a parent and child hierarchy, but there will be a starting tag, there will be an ending tag. But in YML format, it is purely based on the indentation. It will be purely based on the indentation. Like this is parent. This is parent. Let's assume if I refer this one, this is parent. That parent has a child, something like this. This is one child. So two spaces, this one, and its value. If I want to represent this same file in a YML format, this is how it will be. Something like this, group ID. This is the value, something like this. And if I see, this is object. Again, it has some childs, right? So here, it will be something like this. Organization, child of this, name. Something like this. URL. It's a purely based on the indentation, parent and child hierarchy. So in YML format, you will not have a open tag and close tag. This is parent. These are the childs of this guy. And these two are child of this guy. Suppose if I want to define array multiple, right? It will be something like this. Dependencies. Inside that, I can have something like this. Dependency. This is how it will be, YML. And its values. If I want to represent another dependency, something like this. That in YML, in YML, what this represents, guys? This hyphen. YML is basically you are defining some information. This is normal key value pair, string. This is string, key and value. This is object. In YML, I can call this one as an object. This is one object. What is this? What is this hyphen represents? In YML, I am not talking in general. This hyphen represents what in YML basically? Is it a singular or plural? Hyphen represents, this represents what? This is array. List of objects, array or list. This is what? It's an object. This is parent, these two are childs. This is object. What about this? Is it an object or it's just a string? This is what? Just a string. So YML is one format using which we can define some information. We can define some information. So now Docker Compose is again a YML. Docker Compose is again a YML. So how can I define this information? Right? My volumes information, my network information, right? So Docker Compose will have 4 root attributes. Important 4 root attributes. What is the root attributes in the sense? Which will start from the beginning of the file. This is my YML, beginning here, starting from here, beginning. So it has 4 attributes: version, services, volumes, and networks. It is one YML format. It is one YML, right? It is in YML format. I will define this information. Docker Compose has these attributes, root attributes. Now version. Here your Docker Compose version, like you have Docker Compose file format like 3.1, 3.2. This is your Compose file format version. Now, where should I define this information? Under which attribute I can define this information now? Under networks, you can define this information. Under networks, you can define this information, 2 spaces, 2 tab spaces, space tab guys, space, 2 spaces. My value name. If I don't mention the driver, using which driver Docker Compose will create this value? What is the default one? Basically bridge network. Network basically bridge. If required, I can mention again 2 spaces, bridge, driver, bridge. Now where should I define this volume information? It is not always, right, based on what file format you are using. Compose, Docker Compose will have a file format. Like your XML will have a XSDs, right? If your XML, if you see, your XML will have some XSD versions, right? So based on this, your XML will be validated. Similarly, in Docker, you have a Docker Compose file format. Versions. If you see, whatever tags or whatever attributes I am using, that will be based on this. So these are the file formats. Docker Compose. So can I use 3.8 if my Docker software version is maybe 17? Based on the Docker version, your file format option is there. But can I use like 3.4, 3.3 in 18 or 19? Backward compatibility will be there. So this is your file format. So based on your file format, you can use appropriate tags, appropriate attributes. Now, like I can say something like this, 3.0, 3.2, based on your tags which you are using in this compose file. So now I defined a network information here. If I have another network, I can define another network also. If I want to create multiple networks. Now here I define my network information. Where should I define this volume information? So that Docker Compose can create a volume when we are deploying using Docker Compose. This is my YML, right? There are 4 root tags or root attributes: version, services, volumes, and networks. So where should I define this network information? Sorry, this volume information. Under volumes, I can define. Basically, you are converting your commands into a one file. That's it. You are defining your volumes information, networks information. If I want to create from this driver, I can say this driver. Now, where should I define my services? Basically, my containers information. Where should I define this information? If I am using Docker Compose, we need to write a Docker Compose file. We need to write a Docker Compose file. Under services attribute, here I can define something like this. Service name. Service name. You can give any service name. So here, what and all things? Image, ports, volumes, right? Environment, networks. These are the possible options. Now, from which image I want to create this service? I can mention that image name. From which image I want to create this service, I can mention that image name. And port, what is my port binding? What is my port binding? Whatever I want to do. So why this is something like this? Suppose if you have some containers, like you may need to bind with the 2 ports. Suppose if you take Jenkins, Jenkins has a Jenkins port and a slave port, right? You can bind something like this. So port, which port you want to bind, and volumes. For this service, do I need a volumes? This is stateless application. Do I need a volumes? Am I using volumes for this? No. I can remove. I don't need. And what is this environment? How can I pass these environment variables in a compose file? How can I pass these environment variables in a compose file? If you see here, we are using -e. Here, how can I define environment? Under that, you can define key and value. Under this, you can define key and value, something like this. Your value. It is something like this case. Like you can define key and value. We can pass multiple values, multiple environment variables. Now, under which network this container has to be created, you can mention. Whatever network you have created here, this. If you observe correctly, are we doing anything new in a compose, or we are just defining whatever commands we used in the form of YML? Is compose is something new here? We are not doing anything new. We are just defining our volumes information, our networks information, our services information in the form of YML. So this is one service. From this image I want to create. This is the port mapping. This is the environment variable. Under this network, I want to create a container. So now I'll come to that. Is it a best practice? Because these compose files we will maintain in a version control systems. I'll come to that point. So this is not recommended. You should not have a, confidential information in a compose file in a human readable format. Not only in compose file, guys, whatever file, whatever source file which you are using and which we are maintaining in a version control system should not have a confidential informations in a human readable format. So I'll come to that later. So this is one service. This is one service. Now how can I define the other one? This section will be repeated. This section will be repeated exactly, something like this. Another service, just to give an example from this image. This is a backend container. Do I need to do the port mapping? Do I need to do the port mapping for backend container? Are you going to access database from outside? Not required. So port mapping is not required. And environment variables. For this guy, this is the environment variable. This is the environment variable for this guy. And this guy is a stateful application. So what is required here? Do I need to map with volumes or no for this service, basically for this container? So volumes. So this is my volume name. This is my volume name that I mapped with /data/db. So this is how you will write. Suppose your application has 10 services. This will be repeated. This will be repeated for 10 times. If your application has 10 services, this will be repeated for 10 times. And what is the image for that service? What is the environment variables for that service? Do we have any volume mapping? Right? So this is how we will write a compose file. Then what is the difference between Docker file and Docker compose file? What is Docker file? What is Docker compose? So what is the difference, right? Docker file is used to create an image. Docker compose file is used to deploy one or more containers. Can't I deploy one container using Docker compose? I can deploy. If I want to deploy only one container, you have a compose file. You have a compose file with just one service. If I want to deploy multiple containers, you will have a compose file with multiple services. Docker file is used to create an image for one application. Docker compose is used to deploy one or more containers. Suppose my requirement is I want to create this container before creating this container. Mutual dependency or startup order. I want to create this service or container before creating this. What can I say? There is a one keyword called depends on. Depends on this service name. Suppose I have given service name as Mongo. So depends on this. So what Docker compose does, guys? If I define my compose file something like this, will it create this one first? Because here I mentioned this service is depends on this. So startup order. So which one it will start first? Which one it will create? Before creating this one, it will create this one. You have some requirement, something like this. You can define mutual dependency or startup order using this keyword. Now, let me show the compose file for this application. Something like this. But I'll come to this. Okay, there are two things. Okay. Now, as I told, we can give a restart policies. What are the restart policies we have? Right? We have always, on failure, we have never. So these are the restart policies, restart policies. Someone was asked me, sir, when I stop my servers, when I am starting my servers, the containers are not coming up. So that is depends on your restart policy. Suppose if I given restart policy as always in a normal Docker, if you stop your server, if you start your server, do you need to start the containers manually? In a normal Docker, if you have create a container with this restart policy, always automatically it will start. On failure, it will try to restart if container is not coming up successfully. And never, if I say never, will it start automatically whenever you stop your Docker process, Docker server, and if you start again, it will not start. So you can mention the restart policies also, something like this. You can mention the restart policies also, something like this. So this one will not work in a normal Docker. This one, it will not work in a normal Docker. As of now, this is a normal Docker machine. We are not using any Docker swarm concept. This section will be considered only in the Docker swarm, not in a normal Docker. I'll come to that. Let me delete this. This will not work in a normal Docker machine. This will be considered only Docker swarm. So let me remove this. I will show only directly in the Docker swarm. So this is one service. From this image, this is my restart policy. These are my environment variables. This is my port mapping or port binding. If required, you can define a working directory also. Like I no need to mention, it is already part of my Docker file. Now, this is depends on this service. If you have a requirement, you can define something like this under this network. This is another service. From this image, this is the environment variables, volume mapping, right? Restart policies if required, and volumes and networks. So I'll come to that. What is external true? So now I can define something like this, right? I can define something like this. Your driver, if you don't mention what type of driver it will use, if I just say Mongo DB, and if I use that one here, what driver it will use, guys? For a volume, if I don't mention for volume and network also, if I don't mention driver, for volume local, for network bridge. For volume, it will use local volume. For network, it will use bridge value. So now, this is my compose file. So I no need to execute those many commands. Let me remove the containers. So using this compose file, if I deploy, what and all things it will be created, guys? It will create network, it will create value, and what else it will create? It will create this services, right? It will create this services. Now let me write a compose file. I'm having a compose file here. I'm trying to create compose file here. And what is the default name of a compose file? This is my compose file. What is the default name for compose file? Should be Docker hyphen compose.yml or Docker hyphen compose.yaml. YML or YAML. It is one file format, guys. That's it. YML or YAML. Now I have defined a compose file. This is my compose file. I have a version, services. If you observe, now I have not given a name for a container. So how one service, basically one service or one container can communicate with another container? Now if you see, I have not given a name. What are we using now for a communication? If you see, now this guy has to communicate with this container. What are we using here? What is this? Service names. What are we using? Are we using IP? Am I passing IP anywhere? Both are in same network. That is fine. Both are in same network. But earlier, I used to pass container name as my host name. Now what am I passing? What is this? Here, host name. What is my host name here? The service name. So this service or container can communicate with this service or container using service name, since both are in a same network. So now let me validate this compose file. Whether I have written proper compose file or not, I can validate. So what is the command to validate, or what is the Docker compose command? Basically, this is the command: Docker hyphen compose. I can execute this command to validate. So where can I validate? In the directory where I have a compose file. In the directory where I have a compose file, I can execute this one, this command: Docker compose config. But do I have a Docker compose installed in this machine? So we don't have a Docker compose installed in this machine. So this is, I am using Amazon Linux. This is Amazon Linux machine, right? If you are using Ubuntu machine, you can execute Docker. Basically, you can install something like this. If you are using Ubuntu machine, you can install something like this: sudo apt install docker hyphen compose. So if you are using Ubuntu machine, you can install something like this. But here, let me see if it works. Yum install sudo yum install docker hyphen compose. So it is Not there, no package is available. Let me update the package manager and try. What do you do without having a Docker? So if you don't have a Docker, what is the use of Docker Compose? I think what I have done, sudo yum update. So basically that YML you will have as part of your source code, right? If you see as part of your source code, the way you have a Docker file, we have a compose file also. So whenever you clone in your build server, you will get this one also. You can apply. Once you create an image, once you push an image, then you can deploy using compose file in the same directory. As part of your build directory, you have a compose file. So you can create in the server. Suppose you want to maintain in the server, you can create anywhere, but that command has to be executed from that directory. So Docker Compose is not there. So we can install Docker Compose. Let me show the instructions. Whatever, like Amazon Linux. So you can follow this, or you can download the files from the official GitHub. If you see, I have given instructions here. You can download the software from the GitHub, the Docker Compose from official Docker GitHub. You can change the permissions and you can execute. You can follow these instructions. You can follow these instructions, whatever I have provided here. Same thing here, they have given, like you can download from the GitHub. You can change the permissions and you can execute. Or if you want to install using package manager, right, you can install using package manager. This is Docker installation, right? I already have a Docker. I can follow these instructions, which I have already documented here. Suppose if you are using Ubuntu machines, you can execute something like this. If you are using Ubuntu machines, you can execute something like this: sudo apt install docker-compose, something like this. So let me use these instructions which I have already documented. If you see, right, I think it has downloaded as a root. Okay, that is fine. Since I use sudo, or you can do it as a normal user. Instead of sudo, you are just using curl, right? So you can directly install. Now, if you see, I have a Docker Compose installed, right? I have a Docker Compose. Docker Compose, you can use -- version also. So this version of the Compose. This is your Docker Compose software version. This is your Docker Compose software version. That is not we are giving here in the file. File format is different. Now I have a Docker Compose installed. Now I can validate. Since I have a Compose file in this directory, I can validate Docker Compose config. If my compose file is proper, I will see output something like this. If my compose file is proper, I can see output something like this. Suppose let me do some mistakes. I am not following some YML standards, or let me use, instead of image, I am saying images. Instead of image, I am saying images. Let me validate. Now what it is saying? Is it valid? Is it valid? It's not valid. What it is saying? What is the problem? What is the problem? It is saying unsupported config option for which service? For this, I am using this. That is not valid option. So let me fix that issue. Image. Now, sorry, let me do some other mistake. I am not following proper indentation. If you see, this is child, this is also child, but I am not following proper indentation. Now YML parsing error. YML parsing error you will get. So at line number 4, there is a problem. YML parsing. YML is completely based on the parent and child hierarchy. So this has to be here. Now, instead of Spring Boot, if I give ABC, will it throw any error, guys? Instead of Spring Boot, if I give ABC, will it throw any error? Because this is your service name. You can give anything. This is your service name. You can give anything. Now here, if I give MongoDB, it won't give any error. It will create a container. But does your front-end application will be able to talk to your backend? It will create a container, no issues. Because here I have given MongoDB, but here I am passing as what? Mongo. So containers will come up. Containers will come up, but this guy will not able to communicate with this guy. If I give MongoDB here, I should give MongoDB here because this is host name which you are passing. Something like this. Now, I have validated. Let me validate once again. Something like this. Now, how can I deploy? How can I deploy this compose file? What is the command, right? The command here is Docker Compose, Docker Compose up -d. So there are these commands, guys. So for what command I used? Docker Compose. Docker Compose help has provided list of commands. So for what command I used? This one, config, to validate. Now there is an option create and up. If I say Docker Compose create, it will just create the services. It will not start the services. If I want to create and start, what option? Docker Compose up. So let me execute Docker Compose up. What is -d here? Detached. Because if I don't use -d, the services are basically the containers will be created in an interactive mode. I don't want to do that. So detached mode. Now how many services are basically how many containers it will create? In my compose file, I have 2, it will create 2. And also if you observe what it has created before that, what it has created? It has created a network, it has created a value, then it has created a containers. Now, did I manually created this? Or basically did I executed commands to create, or did I use compose file to deploy? We used compose file. But if you observe, what is this? EC2-user, EC2-user for your network name, container name. Network also created with that name. EC2 underscore MongoDB. Network also created with that prefix. This is my compose file. This is also created with that prefix. This is also created with that prefix. And your container names also prefixed with that. What is that prefix? Is it your Linux machine username, or it's a directory name? It's not directory, sorry, it's not a username, guys. Basically, this is your current directory. So basically, it is trying to consider that as your project name. So current directory. So this is the current directory. So that is considering, this is basically a project name, your directory name. So it is not username. It is basically a directory, the current folder. Suppose if I am executing this one from this application, Spring Boot, inside this directory I have a compose file, and if I apply, what will be the prefix? Inside this directory, if I have a compose file, and if I apply that compose file from this directory, what is this? Basically, this is your project name. Your project name. It is not a username. It is not a username. It is basically the current directory name. From which directory? Basically your project directory, from which you are applying that compose file. If I want to terminate, if I want to delete, what command I have to use? There is a command called down. There is a command called down. But is it deleted volume, guys? When I terminated, is it deleted a volume? If you observe, because volumes are important, right? If I want to create, I can execute something like this without updating your image version. If I try to execute one more time, what is going to happen? Is it recreating your services? If there is no change in your image version, you are deleting the containers. Docker Compose down, you are deleting the containers. You are removing the containers. Now, if you see, without change in your image version or some changes, is it again recreating the containers? When I am using Docker Compose up, what it is saying? What it is saying? It is up to date. There is no change. Suppose there is a change in my image version. Suppose my front-end application image version got updated. There is a latest image which I want to deploy. Now, My image version got updated. I want to deploy this. So what it is done? Is it recreated the database container, or it is only recreating this, the whatever application got changed, whatever service version got changed, only that one. Now, if you see, these containers are created by a Docker Compose. Okay. So tomorrow also we will continue for continue on Docker Compose for first 15-20 minutes. Then we'll try to discuss about Docker Swarm. Okay. First 15-20 minutes we will continue on Docker Compose. Then we'll try to understand about Docker Swarm, guys. So Docker Swarm is a tool using which we can define and run multi-container applications. So same application, right? This application also we can build and deploy from the Jenkins using Compose file. This application also we can build and deploy from Jenkins to the Docker using Compose file also. Okay. So here you can see the sample Jenkins file for that. I think I have, this is for Docker Swarm. Okay. So using Compose file, we are deploying. Using Compose file, we are deploying in the Docker Swarm, right? Maybe you can practice this one when we go for a Docker Swarm. Okay. If you want to deploy in a normal Docker, this is how I am deploying. I am copying the Compose file. You can execute Docker Compose up so that you can deploy in a normal Docker server. This Docker file, this Jenkins file is for Docker Swarm. So when you want to deploy in a normal Docker machines, don't use this command Docker stack deploy. In a normal Docker machine, execute Docker Compose up. So we can build and deploy. We can build and deploy using Docker Compose file also from Jenkins. So tomorrow we'll continue on dynamic tag, right? SCD command. So you can apply that logic. So here, this is your Compose file which you are going to maintain in a GitHub. Here, instead of giving something like this, give some placeholder. Before you are copying into your deployment server or before you are applying, use SCD to replace this build number with whatever build number you have. Maintain something like this in the version control system. Once you clone this project, you will get this Compose file. Create a Java package, create an application package, Docker image, push the image. But before deploying, you need to replace this placeholder with whatever current build number or whatever image version you pushed, then apply. So you have to use some kind of a scripting, right, to replace this build number with the actual image version. So try this way, guys. Okay, it will work. SCD, right? Try to replace this one with that number. It will work. So mostly we will use Docker Compose Yes, if you are using Docker with Docker Swarm, if you are using Docker with Docker Swarm, yes. Suppose if you are using Docker with Kubernetes, if you are using Docker with Kubernetes, you will not use Docker Compose. That we will understand later. What is the use of Nexus in Docker, right? So Nexus, what is the use of ECR? What is the use of ECR? What is ECR? A repository for images. Similarly, Nexus is also repository. So you can push and pull images to the Nexus also. You can use your Nexus as a repository for Docker images. So there is already video available in our YouTube channel. Maybe you can go through that, where we are using private repository. So as part of this one, we are using Nexus repository. As part of this video, private repository, I am using Nexus as part of this video to pull and push the images from Jenkins. We'll continue tomorrow, guys. We'll continue tomorrow with Docker Compose. Then we will start Docker Swarm. Guys, try to practice whatever we are discussing here. Just create a simple, sample Docker Compose file and try to deploy and try to play with Compose so that you can understand.